Hello, everyone. My name is Yajie, a third-year PhD student and a research assistant in Civil Engineering Department at North Carolina State University, and under the supervision of Dr. Kevin Han and Dr. William Restorff. And today my topic is about the NCDOT project, applying smart UAS to produce survey-grade geospatial products for DOT pre-construction and construction activities. So this is the information of this project. This project starts from August 2019 and will end this October 31st. So in the research team, Dr. Kevin Han and Dr. William Restorff is the PI and co-PI respectively. And I'm the research assistant who is responsible for this project. And also we hired a special data consultant as the LiDAR data collection subcontractor. And for the administrative team, Curtis Brandley from Research and Development Unit is a project manager, and Webster Moore in Photogrammetry Unit is the current chair. So with the technological development in advanced software and hardware, such as structure from motion, computer vision, photogrammetry, and remote sensing techniques, unmanned aerial systems can be equipped with non-metric cameras and the LiDAR sensors for manning, surveying, and mapping applications, such as the real estate and the construction, as you can see in the figure 3. So those techniques allow 3D scene structure, camera poses, and the orientations can be reconstructed from the 2D images with a high spatial resolution. So there are so many conventional softwares to do the 3D reconstruction. The principle of the 3D reconstruction in those commercial software is a feature extraction and feature matching. So in the feature extraction process, the visual features such as the scale invariant features are extracted from images, and the extracted features are going to the feature matching process, where the features from each images is matched with the same features from the other images. However, the conventional software that accompanies those techniques produce some inconsistent and unreliable survey results. For instance, if you use a non-metric camera, the scale of the models are not consistent, and the camera angles have some issues using the long image overlap and the deflection and distortion images. As shown, these figures can fail the feature extraction and matching processes. So the NCDOT has issues about generating the consistent results. Moreover, there are no guidelines for ensuring the quality of the data. Without the proper guidelines, specifications, repeated serving at a designated area over time, like construction site or with the period data collection, is not ideal. So this research proposes to develop a comprehensive set of guidelines, specifications, and recommendations for producing survey-grade geospatial products using UAS solutions for applications in pre-construction, construction, and slope sites. To develop those guidelines and specifications, there are a series of data collections and evaluation tests with several settings and configurations of the sensors and UAS platforms at 6 different sites with varying terrain types. And there are 2 data collections that are performed to capture changes in each site. So the collected UAS images are processed using 3 different software to evaluate the influence of the different flight configurations and settings on the geospatial products, and the strategies for continuous surveying for capturing construction progress and the changes in terrain. And later, a statistical analysis is used to quantitatively evaluate the relationship between the impact factors of the flight configurations and the accuracy. And then lastly, a UAS workshop was held to assist the NCDOT photogrammetry unit on generating point cloud with consistent quality from image. So for data collection, the first 2 sites are the preliminary sites to practice data collection, which are located at NCDOT campus. The first one is Trucker Facilitator site, and the second one is Lake Raleigh site with a small dam. So these two sites layout are shown in the below figures. And the rest of the four sites are the US test site coordinated by NCDOT, including one NCDOT US test site, which is in Bonner, North Carolina, listed in figure 8 in the left corner, and there are two construction sites. The first one is U2412A construction site in High Point, which is in figure 9, and the second construction site is R2703 EP site, shown in the figure 10. And the last site is a rock surface site, which is in Mars Hill, North Carolina. Here is a steep rock near the highway, which is in figure 11. So for the data collection, both US image data and the LiDAR data are collected in each NCDOT coordinate site. So regarding the US data collection, DJI Inspire 2 with DJI ZenMax X5S cameras with two different focal lengths of camera lenses are used. And regarding the LiDAR data collection, we hired a special data consultant to collect the LiDAR data as a ground truth and to evaluate the accuracy in vegetation areas. And here are the components of the LiDAR, including a Microjones MD4 3000 airframe and one Region Mini VUX LiDAR sensor. And for data processing, the data processing here refers to the US image data processing. We use three different softwares, Agisoft, Pix40, and UAM Master to process image data. And following the flowchart shows the workflow of the data processing from the import all the image data and do the photo alignment in the initial processing steps. Later, we import all the ground control points and checkpoint coordinates and place the markers on the different images, and then build the point cloud and check the accuracy from the generated quality report. The other optimal settings was used to achieve a high quality of the accuracy. And then is the data evaluation. The first step of the data evaluation is the spatial data assessment, which is according to three accuracy standards, because the maximum accuracy is detected by the ground sample distance. According to the Federal Geographic Data Committee Geospatial Positioning Accuracy Standard, the accuracy should be reported using root mean square error in easting, northing, horizontal, and vertical directions, and based on 21 North Carolina Administrative Code 56 specifications for surveying. Horizontal accuracy is generally classified as 5 classifications, from Class AA to Class D. Here I listed the first 2 classes that I used in this project. So Class A surveying in horizontal direction, a 95 confidence level is less or equal than 0.1 feet. But for Class A surveying is less than or equal than 1.64 feet. So the horizontal accuracy class values have the too large range to adequately define the large-scale area survey data. And also for the vertical accuracy in 21 NCAC specifications are based on the ground survey techniques, which cannot use to measure the errors such as RMSE. So in 2015, American Society for Photogrammetry and Remote Sensing National Accuracy Standards for Digital Spatial Data published the new standards for horizontal and vertical directions, which combines the previous standards. And the new standards shown in this table can classify the horizontal and vertical accuracies on centimeter levels. And as you can see from this table. According to the data evaluation, we found several reasons that cause the inconsistent and unreliable results, such as camera calibration. Only changing to the fixed camera settings of the pre-calibration can cause the inconsistent results. And also, image with a poor quality can significantly influence the alignment results, and the camera exposure parameters, such as the shutter speed, lens aperture, and ISO values have a considerable effect on image quality. Also, a level of motion blur will significantly affect the accuracy of the measurement, and the quantity and the distribution of the ground control points can influence the error triangulation and eventually affect the accuracy results. Moreover, the site conditions and the environmental conditions also can affect the accuracy and cause the inconsistencies. So another thing we do is about the statistical analysis, which we call multiple regression analysis, to evaluate the relationships between the accuracy and the impact factors of the other flight configurations, and also to identify the level of significance of the impact factors. Also, a multiple regression prediction model was developed. It's developed using the multiple regression analysis to estimate the accuracy. To develop this model, 40 flight missions were conducted at track facility site using 4 different flight heights, 5 different image overlaps, and 2 different focal lengths of camera lenses. And when the processing the image for the 3D reconstruction, 4 different sets of ground control points with other 40 flight configurations, which led to 160 combinations of data of the data set were processed. And here we show the basic multiple regression models that we use to build our own prediction model. And the results of the Unmanned model is validated using data collected from the NCDOT banner site. And you can see this table shows the results from the banner site, from the Pix40 and the predicted Unmanned model. The difference from the Z vertical directions from Pix40 and the Unmanned model for 2 flight missions is 3 and 7 millimeters respectively, and the difference of the horizontal direction from the Pix40 and the Unmanned model for both sides for both flight missions are only 2 millimeters. So we can say the Unmanned model can be used in practice to identify the relationships between the dependent and the independent variables, and also to identify the relationships between the independent variables. And also we can estimate the dependent variables based on the independent variables. Here, the dependent variables is the accuracy, like RMSE Z and RMSE R, and the independent variables are the values of all the impact factors of flight configurations. And we can use the Unmanned model before conducting the surveying missions to have a basic understanding of the what level of accuracy can be achieved, and also for the flight missions with constraints or limitations to better design optimal flight missions based on site constraints and the limitations. And for building the Unmanned model, you can use the existing data if you have the sufficient data set. If not, you need to collect a new data set with different flight configurations and flight combinations. So another thing that NCDOT wants to know is about how many ground control points are needed in different sites to achieve a desired accuracy level, such as Class AA. For example, using 6 JCPs for 1 acre of land can give you AA accuracy, but can you expect AA accuracy for 20 acres of the land still using 6 JCPs? So this research can potentially answer these questions. As we all know, the quantity and the distribution of the ground control points significantly impact the accuracy. However, the ground control point displacement and the measurement is time and labor consuming. So understanding how the GCP quantity and the spacing can impact the accuracy and identify what is the optimal separation distance between the ground control point is important. And the following figure shows an example of how we display the ground controls on the site to assess the accuracy. And the last thing I want to talk about is the US utilization workshop, which was held in July 7, 2020. The topic of this workshop is about generating point cloud with a consistent quality from images. And the objective of this workshop was to understand the concept of the 3D reconstruction and the camera calibration distortion, and also learn how to deal with the blurry images with fix the inconsistent models by removing bad type points and adding new manual type points. The manual type point is the 3D point corresponding to a feature that is marked by the users in the image, and it is used for the assessing and improving the reconstruction accuracy. And thank you for listening to my presentation. Any questions?
All right, thanks, Yajie. We're going to take questions at the end of the discussion. Okay. All the questions will be taken at that time. Yeah. All right, we will now start with the panel discussion, and we're going to start with Nicholas Shirt from NCDOT Photogrammetry Unit, and followed by Mark Ward from Location Service Unit.
Hey, thanks, Richard. Can everyone hear me all right?
I can.
All right, great. So let me share my screen. And then let me just swap screens. All right, I'm gonna hide this. All right, so hopefully now you can see the title of the presentation.
Yes.
All right, great. Well, I'm going to go ahead and get started. I'm going to, for the sake of time, I know there's a lot of other people on the panel that are going to talk. So I'm going to try to go pretty quickly and be vague. So if there's any questions, like Richard said, you know, of course, feel free to ask us at the end. So I'm here to talk about UAS technology for small site surveying and other transportation applications here at the DOT. Again, my name is Nick Short. I'm a licensed professional engineer with the state of North Carolina, and I'm the assistant state photogrammetric engineer for DOT. I also have tagged with me too is Mark Ward. He's a professional licensed surveyor. He works in the location and surveys unit, and his official title is a sonar operations engineer. So quick presentation outline. I'm also going to talk on behalf of Division of Aviation and go over a couple things that they've been doing and what's come for them. And then, of course, I'm here to talk on behalf of the Photogrammetry Unit. So we're going to talk about some things that we've been doing and some things that we'd like to do regarding UAS and small site survey grade mapping. And then Mark Ward is going to come in right after me, and he's going to talk on the location and surveys unit side of things here at the DOT and talk about what they've done and some things that they'd like to do. Again, here, you know, since we work for the DOT and the government, you know, we want to spread awareness and knowledge. So again, I'm assuming most of everyone here knows about the regulatory considerations for operating a small UAS, but you got to meet both federal and state side for just operating the UAS. So the federal is the Part 107, and then depending on what state you're in, here in North Carolina, you've got to do some specific training and get another permit to operate a small UAS in a commercial or government project or fashion. And of course, the NCDOT Division of Aviation has the responsibility, and they're the ones that, you know, came up with these rules and regulations, and there's kind of the responsible party here for the state of North Carolina. Now, speaking of Division of Aviation, they've been leading a lot of other things, and not just only the rules and regulations. They completed the first bridge inspection in North America with the Skydio drones. They have helped location and surveys get over 30 plus pilots throughout the state. And I think, not including location and surveys, the DOT has over 100 licensed pilots for small UAS systems. And location and surveys also has 7 RTK systems. Division of Aviation is also the first to obtain a BV loss waiver in North America, the Beyond Visual Line of Sight. They plan, I think they were supposed to do that today or this week. I think it got postponed, and they're going to do that later on sometime this month. That's in Ocracoke. Oops, I made a mistake. Division of Aviation has also been heavily using the wing to vertical takeoff drone. and doing large, I guess, orthos and mapping and monitoring of projects and such for that. And they also delivered the first COVID vaccine delivery by drone in the USA. So things coming, of course, the longer mission in OBX, that's the beyond visual line of sight that they're going to do out in the coast. They're also going to implement a drone in a box in Division 9, as well as implementing a LiDAR sensor on some of the UAS systems. So again, if you have any questions, I think Tom Walls with Division of Aviation is actually here, so maybe he'll be able to answer some questions if anyone has questions specifically towards these past 2 slides. So that being said, I'm going to kind of jump into kind of give an introduction of the surveying side, and then I'm going to go into what photogrammetry unit is doing, and then transition over to Mark Ward with location and surveys. So again, for doing survey grade products, spreading knowledge and awareness that you have to be working under the responsible charge of a professional licensed surveyor in North Carolina to generate any type of survey grade products from both manned or unmanned aerial sensors. These products include orthophotos, orthomosaics, point clouds, ALS files, elevation models, essentially anything that involves coordinates. Again, I keep talking about us 3 units. We've kind of put together and developed a aerial surveying program business plan. So this is just for the surveying side of the UAS. And so all 3 of our units, or I should say Division of Aviation, and then photogrammetry unit and location and surveys unit is all trying to work together to implement this business plan and really kind of have a strong surveying program with UAS across DOT here in North Carolina. So now I'm going to talk about a couple of specific projects where we photogrammetry unit has processed and done some testing on some things and trying to kind of just come up with some lessons learned and just get a feel for how this technology can benefit us. And so here we decided to do a test on point spacing for some DEMS when we're doing earthwork volume quantification. So when we, normally when we fly and we process all this data with the UAS and the structure for motion algorithms, you generate a highly dense point cloud. So for this specific project, you can see there, the green outline is the project limits. So that's the area we were trying to quantify of dirt that was being cut or soil that was being cut. The dense point cloud, I believe, had something like 39 million points. And so processing that and doing calculations of before and after the dirt was moved, that can take a long time to generate those 39,000 or do calculations. So we decided to decimate this, and we were like, okay, should we decimate this to 2.5 foot spacing or a 1 foot spacing? And so you can see here, I don't know if you can, hopefully you can see my mouse, but if you come here on the 2.5 foot spacing, and you can see our cubic yards that we calculated, and then here's our 1 foot spacing, and you can see our cubic yards that we calculated between the 2.5 and the 1 foot spacing was almost identical. I think they're not even 40 cubic yards off. So between the two, we saved we saved, so the 2.5 foot spacing had, I think, roughly around 600,000 points. So we dropped down from 39 million roughly to 600,000, and then or sorry, the 1 foot had the 600,000. The 2.5 foot spacing had less than 200,000 points, and so you can see and the big win here was the calculation and the processing, sitting there, watching the paint dry, waiting for all this to do the calculations. And we really saved some time there. So now for all of our earthwork quantification projects that we do, we stick to the 2.5 foot spacing. Another kind of interesting project and lesson learns we have here. This is actually one of our first UAS projects, I think, to my knowledge, that we photogrammetry unit really worked on and started getting involved with. And this was back in, I think this was in 2018 during Hurricane Florence. So we had a washout on US 421. And here there was some construction monitoring that we were doing. We were actually not flying this. I believe this was another unit or division was helping us, but we were doing all the processing and we were doing some testing and things like that. And so all this data here was compiled from us. And you can see here all of our missions. Sometimes we flew the same spot twice in one day. Sometimes it was every other day. Sometimes it was only down here about to once a week. roughly, but you can see our first mission, we had insufficient overlap. Don't remember off chance what our overlap of imagery was, but it was less than 80/80 both forward and side. So we decided to bump that up to roughly 85 forward lap and roughly 80% side lap. You can see the ranges here, and we started getting much better image matching and much better results, and that was nice. But if you come over here, you can see our root mean square errors on our ground control points were all over the place. They're inconsistent for the most part, and it just did not produce or did not give us accurate, feel good numbers for survey grade mapping. So we knew we had to control this imagery to get accurate, to be able to take accurate measurements. So down here is when we started controlling the mission, and here you can start to see we start to get in the tenths or less than a tenth of a foot root mean square error, and that really makes us feel good, and we're happy with those results. Now you can see here, this one red highlight is we got almost a half foot in the X direction of our MSE. And that was a controlled mission, and you're probably wondering what the heck happened there. So we actually had a lot of shadowing. I think this mission was flown later in the day, and so there was a lot of shadowing, and just the structure for motion algorithms did not like that, and it produced very inconsistent results. So that was a good lesson learned there. Definitely have to be careful of shadows. Here again, this is the same project. Of course, we've built a bunch of mosaics, and we've got a swipe map. This is a link here. I'm not going to click on it for the sake of time, but there's lots of before and after shots here. You can see on the left. This was flown September 28th, 2018. You can see kind of the washout, and then here was later on the next month, towards actually exactly about 30 days later. You can see that the road was already starting to be reconstructed and built. And then the last one I'm going to talk about before I pass this off to Mark Ward is our emergency response at Walnut Creek Slide. This was out in Madison County on Walnut Creek Road. Here we were just delivering a digital elevation model to our customer, and one of our biggest lessons here was we had some issues with vegetation, and we've seen this in the past before, where some of that structure for motion algorithm has trouble pixel matching in that highly vegetated areas. But other than that, this project was an all-around win for us. We had a really quick turnaround, and in areas where there wasn't heavy vegetation, we had incredibly high accuracy, just as we'd expect, and we were comfortable delivering this as a survey grade, accurate product. But anyways, that's all I have. I'm hoping this presentation will get sent out to everyone, and there's contact information at the end of this slide as well. You can go back and click some of these links. But some lessons to learn that we'd like to kind of continue to test and do things and be involved in this UAS technology is trying out different vehicles and sensors to see if we can even improve our survey grade mapping accuracy, or maybe improve in those shadows and highly vegetated areas. Also looking into maybe artificial intelligence for feature classification. As well as we keep hearing that kind of the industry standard for the GNSS IMU in UAS systems is the Aplonix that Aplonix supplies and makes, and it seems to be that's kind of the industry standard for one of the best. And I put direction. There's a typo. It should be direct georeferencing. But anyways, that's supposed to be one of the better IMUs, GNSS IMUs for direct georeferencing. So anyways, I won't take up any more time.
Yeah, let's pass it over to Mark Ward. Mark, you up?
All right. Can you hear me?
Yes, we can.
Okay. I'm just going to go, quickly through here and just kind of give y'all an idea what location and surveys unit's been doing with the UAS. We've been working on this for the last couple of years in conjunction with aviation, and we're working with photogrammetry as was mentioned before. Right now we have 30 plus Part 107 pilots in our 16 offices across the state. The idea is having pilots close to where things can happen and not having people having to travel a long ways. So that's one of the reasons we kind of got that going with each of our offices. At the moment, we got 7 DJI Phantom 4 RTK systems. And we also have one Matrice 210 that has a zoom camera that we have down on the coast. And all of these are from the aviation unit. We've utilized them on some post-tornado and landslide emergency response, some bridge scopings, maintenance, yard stockpile volumes, and we've been testing on some small projects utilizing drone deploy software. It's a cloud-based software that can produce different types of data. So we're in the process of utilizing that and doing some checks and testing. One of our things is in location surveys, we're working to acquire data LiDAR capable drones for some of our future stuff. So we're still working on that. Cost is a little prohibitive at the time, but we're hopefully that'll work out for us in the future. We feel like the LiDAR will be good for our main mission, which is usually preliminary engineering and allow for vegetation penetration and hopefully faster turnaround for DTMs in emergency response situations. Okay, Nick, you can move to the next slide, please. Here's I'm just got a few images here of some of the stuff we've done. This is image of some of the tornado damage down in Brunswick County that we worked on. We were able to get down there that morning right after the tornado went through subdivision down in Brunswick County, almost South Carolina. Next slide, please. This is the slide up near Crusoe, post-tropical storm Fred. As you can see the picture on the left there, and this is along the Pigeon River. That was a before. Basically, I got, that come off some imagery, just some aerial photography, but this was an after. We did some checking on some volumes of how much slide material was in the road. Thanks, our local office worked on that. Next slide, please. And this is a ortho mosaic. Basically, we use drone deploy to create this from 109 photos. This is a three-dimensional image, so you can rotate it and look at it. The trees, you can see where some of the trees are and where the slide basically went through and across the road. Of course, this was done after they had already cleaned it off the road area. Next slide, please. And this photo here doesn't look too much different, but this is actually the ortho with a point cloud overlay. So basically, this is a point cloud. So each, I forget, there's probably, this particular one's probably got somewhere close to 1 million points in it. But as you can see, one of the interesting things about this that I will mention, that tree kind of in the middle next to the road there, the guys flew this in a three-dimensional kind of checkerboard flight plan with the camera in a oblique position, not a native position, looking straight down, and they were able to get some of the surface underneath the trees. So in the point cloud, you could take the tree out and you still had a surface underneath. Usually can't do that too often on heavy canopy, but just so happened those trees just had high leaves on them and trunks going down to the bottom. Next slide, please. For us, standard projects needed. The resident on the R2303 project asked me to go out and do some basically some flights, just to kind of give them an idea of the progress of their project. See these two photos. One was taken in July of 2020. Next one was taken in November. You can see how things had changed over time. Next slide, please. And then I did some bridge scoping. I had a video, but it ended up being too large for what we were doing here, and it worked out better. But I just did some scoping for Division 6. We flew on this, and for a bridge scoping, they had some images and video showing the bridge that they were going to do some replacement on. So kind of gives you a record of what's there before you start your surveys, and you can go back and look at different things as time goes on with different contractors and different things. The bridge project manager, I heard, really appreciated us getting this for them. Next slide, please. I did a project on Southport, the spoil site on the ferry. A top left photo there, if you notice, the berm had been eroded out in some areas. They were going to do some construction to replace the berm, extend the riprap along the edge for protection. Both of these are utilizing drone deploy and bringing the point cloud into ORD. So next slide, please. And then this was the an ortho showing after the construction had been done. If you look a little close on the far left side there, you can see where the berm was put back in place. They had took some of the spoil out of the site, and we figured some volumes for them on how much earthwork was moved between the different berm areas and the pit itself. Next slide, please. And then here's a maintenance yard stockpile that our Division 6 people guys did with drone deploy. Just some volumes for the maintenance yard. Next slide, please. And this is another picture of that, just in a different, the little dots on it, that's some control we had set when they were flying this. Next slide, please. Possible uses in location and surveys. We're looking at supplementing data with photogrammetry. One of the ideas that we've thought about is this could possibly use for construction projects, analyzing erosion control after large rain events. I think this would be documentation and to get an idea of how much silt fence or areas get blown out if we get a bad rainstorm. We're looking to use for intermediate volumes on small borrow pits, earthwork projects, small project updates. I've got a couple of offices wanting to utilize some stuff on secondary roads and some intersections. And we're always looking for new ways to use new technology to help with our mission as far as producing preliminary engineering projects, which is one of the things that we do mostly. I think that might be about the end. Is there one more slide?
I think that's it.
That's it. Thank you all very much.
All right, and since we'll take questions at the end, I'm going to stop sharing.
Yes, thanks, Mark. I know my background is showing up pretty nicely. It seems like it's backward on my screen. The next speaker is JR and Stephen Robinson from Division 7. Go ahead, Stephen and JR.
Good morning, guys and ladies. We just want to start sharing the screen here. Stephen's going to control that. We're going to go through a few slides we put together. Like you said, my name is JR Hayes. This is Stephen Robinson. We're the drone pilots for Division 7. And before we get started, I'd just like to thank Tom Walls with Division of Aviation for the tremendous help he's been in helping us implement the drone program in Division 7. I don't know we would be where we are right now without Tom. So thank you, Tom. All right, so during this short presentation, we're just going to share a few of the ways that we have introduced drones into the division. As you'll see, there's numerous ways that this technology is being used, and these examples of the use of drones is making a collection of this data safer and a lot more cost-effective for the division. This is some footage of the division office we took just to show what the building looked like. When Ryan Archer became the division engineer in August of 2020, implementing a drone program was one of the first things he requested, as he had seen the benefits while he was serving as division construction engineer in Division 9. So he brought that with us, and we tried to take a hold and run with it. This is of some routine footage of construction project of an urban widening we're doing on Ski Club Road in Greensboro. These progress images and videos are very beneficial when municipalities request updates. If there's any claims from the contractors or simply to get a better look at the operation, we use these footages that's been collected to help us in those times. I've also began collecting pre-construction footage, and we're going to start working on some time-lapse videos to show the different construction processes. Drones have also been a useful tool in inspecting for erosion items when access by foot or by vehicle may not be accessible after a big rain event. There's a short video that was taken from the 119 project in Macon, just to see some of that footage. Bridge inspection is another avenue that we've used to use drones in. Temporary bridges are often in service for several months and have many components that require routine inspection. The use of a drone allows the user to take a quick look at the temporary structure between these routine inspections, just to make sure that everything underneath seems to be as it should be. We had a project in Chapel Hill this past year that was a bridge rehab project, and the drone allowed inspection of the repairs without having to have an employee on the scaffolding or using a man lift. This is a video of where a drone was able to go up in between the girders and do some inspection that was a lot safer and easier than putting a man up there. This was a special drone, I believe was mentioned earlier in this presentation, is the SkyDO, which has the crash avoidance sensors on it. As you can see, you can get real close into the girders and see if the repairs that were made were substantial or if they were accurate. We've also used the drone for new road openings. There's numerous benefits to this, to provide aerial image to local news or outlets if they request footage. And this was actually the soft opening of the urban loop in Greensboro in December of 2020. The picture you're looking at here is where we were asked by the division maintenance engineer if we could help locate a couple beaver dams that were causing backup of the stream. And that was actually causing flooding on a private property. So we used the drone in this situation, located those beaver dams, and they were eventually taken out. We've actually started using, kind of like what Mark was talking about, doing some stockpile calculations. This is from a stockpile that was flown in Nevins to determine what cubic yards would need to be wasted on this project. It was done in less than half the time it would take a conventional surveyor to go out and topo the stockpile. We've got a few sites that we store our information on, and like everybody else sees, when these slides are sent out, these links should be active. If you ever would like to see any of the videos or still pictures that we've taken, you're more than welcome to check out these locations. That's pretty much all we had. Just wanted to share a little bit of what was going on in Division 7.
Thanks, JR and Stephen. Certainly, we appreciate you sharing that with us. At least a lot of us didn't know what's going on in Division 7. The next speaker we have is Jaimie Nevins. She do work with the dashboard. She's with DIT, the GIS unit. Jaimie, you are up.
Hi, thank you. Hi, my name is Jaimie. I work as a GIS architect for the Department of Information Technology Transportation. The GIS unit that I work for supports all the Department of Transportation's business needs, which also includes the Division of Aviation. So we've seen that there is a variety of data types that can be collected with drones. And so when it comes to visualization in GIS, that means that we need specific tools and software to help visualize that data. So today I'm going to give you a quick show and tell of some of the products that the GIS unit has helped put together for the UAS group over the years. And these products are going to be specific to large storm events. So everyone probably remembers Hurricane Florence and actually may be quite familiar with this particular map, especially the people on the panel. The UAS program dispatched drone teams across the state to different impacted areas and had them collect a variety of oblique photos and videos. All the pilots were able to upload their imagery remotely. Our GIS application supervisor, Eddie Shipman, and our Geospatial services supervisor, Mary Ellen Perko, were able to configure an in-house solution that read the EXIF data, metadata from each photo and video, and then created a point on a digital map that linked that photo back to a SharePoint page where that photo was uploaded, as we've seen before. So this was the first major collaboration that the UAS program had with the GIS unit during storm events. And so I thought it would be more valuable to show these maps and dashboards and interact with them in real time instead of showing screenshots. So this is one example. Each point location indicates a collection or an individual photo or video. We can zoom in, we can click on each photo and video. And here we see a tile picture of the actual link, which is, if you click on it, is linked back to SharePoint, and you can actually see which team flew it and which folder it's found in. So this was very helpful and valuable for those teams that were dispatching during that time, and to management that was looking at overall damage across the state. So since 2018, Esri's suite of products and dashboard viewers have greatly improved. So this web map viewer was actually made to view the damage from the tornado in February, as Mark mentioned earlier. So as you can see, the visualization and navigation on this map has greatly improved. We now have the ability to show the directionality of the photo and where in the direction that the photo was taken on the map. We can select an area using different sizes, squares, circles, triangles, and the pictures associated with that area shows up on the left. Here we can see how many photos are actually selected in that area. If we click on an individual area in the map, we can see the pop-up showing one photo here. If we select that photo individually, it will take us to that photo on the left-hand side. In a similar manner, we have all the photos within the map scene right now on the left-hand side, but if we were to click on one of those photos, it flashes on the map on the right-hand side. So this gave us a better way to view the photos and better orientation of the photos on the map. So the latest products that we've been working on include a Survey 123 that has been made to collect UAS mission requests and a dashboard to monitor those missions. So we're still in the developmental phase, but we hope to have it completed within the next major storm event. So Survey 123 is an Esri mobile application which can be accessed within a browser and on a mobile device. As far as mission requests go, Survey 123 is a valuable tool in this case because we can collect all of the details of the mission request, but the requester can also put exactly where they would like the mission to take place on the map just by clicking or entering an address. If any of you are familiar with Survey 123, once the survey is submitted, it actually, a point is created on a map along with that location and all the associated data. So this allows us to create dashboards to help monitor the status of flights as they come in. So this is an example dashboard that we put together. It's not in full working condition right now, but this is ArcGIS dashboards. You're probably familiar with the dashboard environment by now. You're able to add a bunch of different components to ArcGIS dashboards. In this case, we have all the UAS mission requests on the right-hand side, a little bit of detail from each one, and everything is interactive. And so if we click on a mission request, it will zoom us to that mission. We can see all the mission details that come from that Survey 123. We can also click on the individual location and we will see the mission details there as well. We click on it again, we zoom back to the map. So pretty interactive. We can also collate a bunch of the other data throughout the surveys, and all of these can be created to be interactive and dynamic. And so we have the mission status here. Each of the missions can either be assigned, completed, or not assigned. So if we're looking to filter the map specifically on completed missions, we just click on completed, and everything's dynamic and everything updates in real time. Similarly, we have emergency requests, and we pulled this out of the survey because we were curious about which surveys were submitted requesting emergency. So we can also select on that and it filters all of this dynamically. We also have which UAS team that the mission was assigned to, so we can do that as well, one by one. So just a quick overview, there's a lot of new interactive products that are coming down the pipe. ArcGIS dashboards is just one of the many examples of how we can visualize UAS data in real time. That's pretty much all I have. I hope it was a quick beneficial review of the way that we use GIS products to help support the UAS program.
Thanks, Jaimie. That's certainly going to help in terms of a follow-up discussion. That's the end of the presentation. So the remaining time we have, we can open for discussion. In the meantime, if we have any questions, can you just put it in the chat? And we're going to try to actually pass the question on to the panel. In addition to the speakers we saw earlier, we're going to have Rodney, Hough, and Matt Macon join in the discussion, right? So I'm kind of monitoring the panel. I'm going to start off with a question from Jaimie, since that's the last one actually just asked. Is this dashboard open to folks outside of the Department of Transportation?
Hi, thanks. Thanks for your question. So this dashboard is a preliminary example of the types of dashboards that we are able to use during emergency management events. So this dashboard is not live right now. It's currently in development. But if you are within the Department of Transportation or any other state organization, you have access, and you have an AGL account, which is an ArcGIS Online account, you have access to ArcGIS dashboards. And so you're able to create and use data in a similar way. So not currently live, but once we go live with it, those within the DOT typically have access to it during emergency events. Yes.
Thanks. I still monitoring the dashboard so far. I don't see any addition, unless Kelly may help me if there's any question in the dashboard I didn't see. The other question I have is for Yajie Lu. From your research, what was the optimal spacing of the GCP points that you were able to determine in terms of spacing the different control points?
Thank you for your questions. I was still doing this research, but based on what the literatures I read from the other researches, so normally they're gonna decide like a different, how many GCPs in a certain size of a site. Such as I found some research is they recommend you to use 0.5 GCPs in 1 acre of land. And there are only one paper I read is about the optimal distance between the GCPs is 65 meters. But this is a facility side, so they don't have discussion about the construction side. So now I'm still doing the research about the construction side. I'm thinking to give you the detailed results later. As soon as possible, I got my results down. Thank you.
Okay, we have a question for JR. What UAS platform and image alignment software are you using? Have you experienced any issues far on accuracy and reliability?
So far, we just recently got the Phantom 4 RTK. Before that, we were using the SkyDO. We have not noticed any, and actually when we flew that stockpile, we flew it with the SkyDO and did not have any ground control points. And compared to what the contract surveyor topoed that, we were within 90 cubic yards without any ground control or any RTK. So far we're seeing good results. With the RTK system, we expect that to come way down.
Okay, still a question for you, JR, I think. Yes, is this for JR for the research? What software are you using to process the stockpile quantities?
We're using Drone Deploy.
All right. All right. I'm still monitoring, right? So far, I don't see any additional questions. So let those questions keep coming. Let me see. I had a question here. Turn my paper. Spacing. Mark, not Mark, I guess back to JR, right? Yeah, JR, I'm interested a bit more with that with the results you get with the temporary bridging expansion. So you just capture the imagery, right? So you're looking for visual inspection, visual defects to identify. That's the only type of inspection you did on the bridges. What about the surface of the bridges in terms of the conditions or lamination and so forth?
Not at this time. I know there has been some work, but Tom's done some, I believe, with some delamination. We have not, but I know that that work is going on. We just use it basically for a visual inspection to get up close to make sure everything looked okay. We actually still sent an inspector up, to do these inspections.
Mm-hmm.
It was not to forego that, but just as an additional resource to see how it would work.
Thanks, JR. I think we have Tom here, right? I know that Tom, you want to add something to your what aviation is doing right now. I know we had a couple of slides for you, right? But since you're on here, do you want to add something more? Give Tom a chance to actually put this question in the chat, or if you want to expand. Okay, division, Mark, can you expand on
Yes.
some of the applications that you think are feasible for location surveys? Use of this drone technology.
Well, in that case, I think we're just looking at anything we could possibly do. I mean, like I said, our main mission is usually pre-construction, but I mean, we're looking at helping any of the divisions or anybody that asks. Our unit usually works all, with everybody in Department of Transportation at one time or another. But we're constantly looking at this technology and others to try to see what we could work with. I mean, one of the surprising things that I thought about is using for the scoping of bridges or projects, and like I mentioned, it seems like JR them are doing it also, is the erosion control. I mean, the one thing good that I talked with some guys out of the Division 3, and we're possibly looking at doing some bar pits down there for them. I mean, one of the good things about utilizing drones and the photogrammetric side of it is you have a photo record of what you're getting versus, you're out there just surveying with a GPS or whatever. I mean, you don't have a picture of what it looks like. So I think this technology is really going to help out as far as that goes, having a visual record of what you're actually measuring and what you're doing. Richard, I got one other thing I want to put out there, is if somebody might want to, is people that are, some of our people that are listening, are they doing any ground checks with GPS or any of their other instruments with some of the flights they're doing? I'm just curious. I'll put that out there in case anybody wants to answer.
All right. Somebody think about that and then come back to you, right? Hopefully they're going to put the question or give us an answer. I do have another question in the chat. Is anyone using drone for as-built bridge elevations and FEMA requirements for verifying embankment, etc.? I think anybody could try. That's an option in terms of Division 7, JR. Did you guys, or even location of service, Mark? The question is, have anybody been using drone for as-built bridge elevation and FEMA requirement to meet FEMA?
We have not. We've been doing all of our FEMA certs still conventional. And to answer the next question, we just recently got the RTK system, so I'm sure Mark can expand on the accuracy a little bit more than we have. We just recently got that platform.
Yeah, I think it does well. I'm very reluctant to say to not do any ground control from the aspect, even you go out and look at a lot of documentation, a lot of people utilizing this, they still say you need to have a minimal ground control to verify. And one of the things I tell my guys all the time, I mean, we're surveyors. We're not in the process of gathering data and just processing data. We want to make sure what we do fits the ground or real things. So one of the things I've even told all of our pilots and our field crews is that when you go and fly something, even though you're using the RTK system, get some ground shots, just ground truth what you're doing. It doesn't take that long, and that gives you a good feeling for what you're doing. So that's kind of my answer for that. As far as coming up, is this RTK system better than a lot of different ones? I think we're still doing some testing on that, but I think it does help out quite a bit.
Yeah, definitely. I would like to see that anytime we as DOT go out there, they need to put some ground control out. I do have a question for Jaimie. What is the process used to acquire the mission data and specific information that being put into the mission dashboard? Is this derived from the UAS request being made to Aviation UAS?
Hi, thank you for your question. Great question. Yes, so a lot of that data is derived when the survey 123 is submitted. That survey 123 is actually associated with a single point on the map. What we've done, though, is included an intermediary ArcGIS online map where the pilots can be assigned their specific mission. And so right now, if you're familiar with Survey 123, there's not a way that Survey 123 automatically sends an email notification when a survey is submitted. Only a point is created on an ArcGIS online map. And so we're working on configuring a webhook, which actually sends an email to a specific number of individuals once a survey is submitted, so the teams can be notified directly that there is a mission request. And so that's kind of where we're at with this project right now. We're kind of waiting on that Survey 123 webhook. But yes, all of that data within the dashboard is collated data taken from that Survey 123. And there's a bunch of different ways that you can organize that within the dashboard. Once we have the ability to assign the missions to the teams, we can go in and symbolize it different ways within that dashboard as well. So yes, feel free to reach out to me specifically if you have any additional questions.
Before you go, Jaimie, right, for some of us, you probably want to explain Survey 123 to some of us. That's a Esri product, or that's something that you, yeah.
Yes, so the GIS unit uses Esri products, and Survey 123 is a mobile, it's called a mobile application. So it's an application that you can download on your phone and access surveys on your phone, but you can also access surveys in the browser, which is kind of what I was showing you. It's very easy to configure, and as a mobile, I'm the mobile GIS architect, and so I kind of run that for the GIS unit and oversee that for the GIS unit. There's a bunch of different types of questions that you can put in a Survey 123, as you saw. You can just enter text, you can select multiple answers, but the biggest component of the Survey 123 is the spatial component. And so you can select a point on the map. And so all of that data from that one survey is associated with that one point on the map. And that's the coolest part, because now we can integrate that into the dashboard and make it kind of a spatial engine. And once you click on that point, that's where all that data is coming from. It's coming back from that Survey 123.
Thanks, Jaimie. We have another additional question here. What is the realistic anticipated accuracy from these smaller Phantom 4 type drones as verified by random checkpoints? Anyone can answer that who've been using Phantom 4, RTK or Phantom 4. What is the realistic anticipated accuracy?
Richard, this is Rodney. I'll interject that with proper control in our bar pit work we've been doing, we've been able to, we strive to achieve 1200ths of a foot in the X and Y, and sub 1800ths of a foot in the Z with proper control. And based on our checkpoints, we seem to be hitting that pretty consistently.
That's actually, again, thanks, Rodney. I happen to know your name, right? Proper control, what are you talking about? I mean, you're talking about control, enough control and set out for the particular project, the number of control. What do you consider proper control?
Yes, again, it's going to be project dependent on the size and the configuration of the boundary and everything, but proper control, you know, minimal would be 4 control points with one in the center of the project. You know, on longer and more narrow corridors, we're going to, obviously we want a little bit more control than that. But, you know, typically we'll try to put out at least 4 control points controlling around the corners and then one in the middle to hold it up. And that seems to work very well for us.
Okay, thanks. I do have a question for everyone, right? What are some of the things that, since you guys were actually flying this drone in terms of the field work, that everyone experienced in flying the drone in terms of atmospheric conditions, field site operations, working in construction sites, this type of thing? Can you share some of your experience that you had when you're actually out in the field?
Yes, I'll take this question. One of the things that we experience is a coordination with all the different crews and workers on the site to make sure that the site is actually shut down. Because one of the drawbacks on the structure for motion algorithm is that moving scenes tend to cause less accuracy in the end result of your geospatial product. So being able to coordinate a site shutdown for at least an hour on construction sites or a bar pit can tend to be a hassle sometimes with contractors because they don't want to shut down because they're losing money because they can't move soil. Another aspect of flying a drone out in the field is dealing with different atmospheric conditions that can change in a matter of minutes or hours, depending on how long you're out in the environment. I'm sure the guys who actually flew during Florence or right after the hurricane passed can speak to a lot of those adversities.
Thanks. We have a couple of minutes more, right? And I want to give, I don't see any more questions in the chat, but give the presenters a chance to wrap up some of the things they presented that they're able to share, if they want to expand on anything that they think that would be helpful, right?
Hey, Richard, this is Mark. Basically, I thought I'd just mention, I mean, we're really, location surveys is just, we're still working along, getting going on our utilization of drones across the state. But, you know, if anybody has anything that they want to try or anything they want to see if we could get this to work with, I mean, we're open to trying to help anybody out. If there's any of the other units listening, to see how it works and to see if we can gather data in a, you know, a different way or get them different perspectives of their project. Because I mean, I think that's the idea behind drones, is it gives us a different viewpoint, a different way of gathering data. You know, part of what we do is train, check data, make sure it's you know, flying in a drone is the easy part, is what I'm kind of finding out. As Matt said a few minutes ago, you know, the atmosphere, you know, where you can fly, you know, we just can't do it everywhere, but, you know, utilizing them as much as we can, I think will be a big help going forward with NCDOT. I feel like this is a good technology that we'll expand on as time goes on.
Yeah, I think there's a lot of opportunity out here for improvement and use this technology going forward. I want to give the last word to Yajie. If you have anything you want to add about your research or what you want to share with us at this time.
Actually, no. I just want to share probably the last thing about the impact factors. Based on what we found, the impact factors, if you use high overlaps and add more GCPs, you will definitely improve a lot of your accuracy. So this is the only things you can take care of when they're flying drones, and the rest of things like fly high, yeah, And the image quality actually is not so important compared to the image overlaps and the GCPs. That's all. Thank you.
Thanks. Right. We probably have a minute more to wrap up this session. I think we could take one more last question if anybody have one, right? Or anybody want to share anything. JR, you have anything to share? I'm going to move around the room.
I believe there was one question did get answered about whether I used when we compared the stockpile with the contractor, that he conventionally surveyed that. It was our drone compared to his conventional survey. And so, and then the next part of that question was there a difference between the results satisfactory? Not for me, because I'm a surveyor at heart. That's where I started. This was used basically as just a test section, just to see what kind of results we could gain. We still use their information for the stockpile quantities, but just as a test, like everybody else is doing, to see how accurate this information is, and without using ground control points and stuff like that. So, you know, for something like that, I would still, as of right now, I'm not a photogrammetrist. So if we were going to use it for any type of pay items, I would still go that route and set up ground control on those items. But it was just a good test, I thought, to see where the technology was, you know, with what we currently had and how it did compare.
Yeah, I think there's a lot of opportunity for use of drones, right? So I'd like to thank everyone for this question. We're right up to the hour, and appreciate you participating in this panel discussion. Obviously share, and I think as we expand the use of drones within NCDOT, we certainly have the opportunity to have more sessions like this. So thanks everyone for this participation.